Hello, hello. My name's Elder Volel, and I would like to share with you the most amazing book. Hello, hello. My name's Elder Volel. It's a book about equations of perpendicular lines, the book of Algebra 1. And scene. Can you tell that I'm a trained singer? Hi, friends. What's up? Class 12 of Unit 4, our last class of the unit. Let's talk about equations of perpendicular lines, whatever that means. So last time we were together, we chatted about parallel lines, our first of two quote-unquote special cases for how lines on the same plane might interact. And for our second and final act, what makes two lines perpendicular? So I've gone ahead and taken the liberty of drawing you some perpendicular lines here. Take a look at these guys. There's something interesting enough about them that it's worth documenting and giving its own name. What seems to be the case here about these two lines? Maybe you already know what it means for two things to be perpendicular, maybe you don't. Either way, tell me something that you observe here. No wrong answers, except there is a right answer. Go ahead, take 30 seconds. Alrighty, so if I'm working with two lines that are perpendicular, just like parallel lines, we have a symbol for perpendicular. By the way, don't ask me the etymology of this word. I don't know where it comes from, and I couldn't be bothered to look it up. If two lines are perpendicular, the way that we indicate that, say that we have line L1 and L2, just like parallel lines have that kind of little two lines next to each other symbol. For perpendicular lines, their symbol looks kind of like an upside down T. It's not exactly an upside down T, but that's kind of what it looks like. The reason why we've made this choice is because perpendicular lines, if you didn't already know, the thing that's unique about them, notice unlike parallel lines, they do intersect. And when they intersect, they form a special kind of angle called a right angle. So, by definition, two lines are perpendicular if and only if, right? The only way for that to be the case is if they intersect at a right angle. And we know that right angles, they are special. They have a certain kind of measurement. Right angles are all what kind of angles? 5, 4, 3, 2, 1. A right angle is a 90-degree angle. That's pretty hot. So we know that for 90-degree angles, sometimes on a graph, hopefully you've seen this before, you can indicate them using that kind of square shape here. What that means is when these lines cross each other, they're forming a 90-degree angle. In fact, all four of the angles that they form are 90-degree angles. Fantastic. If you're thinking strategically, there's something for us to notice about the graphs of perpendicular lines. And when we were talking about parallels, we said something about their slopes. Maybe, just maybe, wink, wink, nudge, nudge, something about the slopes of perpendicular lines is interesting enough for us to make a similar observation. Take a look at these lines that I've graphed for you. Can you tell me something about their slopes? What do they seem to have in common? What seems to be different? Go ahead, play around, see what you come up with. Have fun. Alrighty. Well, if I take a look at my lines, let's take a look at this first pair here. If I can find some points, I can find some slope. It looks like on this line over here, I've got a nice point there and a nice point there, my little x-intercept. On my other line, it looks like I've got a nice point here and a nice point here. Hopefully, if you're thinking about slopes, the first thing that you noticed is that these lines, in both cases, their slopes, one of them is positive and one of them is negative. One of these lines increases from left to right, whereas the other one decreases. So we know that the signs of the slopes are flipped. Interestingly enough, there's something else about the slopes that are flipped. Take a look here at this guy. If I think about slope as rise and run, notice the run of this line here that's decreasing is 2, and the rise is 3. I know that it has a negative slope, so this guy's slope would be negative 3 over 2. But for its paired perpendicular line, its rise here is 2, its run is 3, and this line has a positive slope, so its slope is positive 2 for rise over 3 for run. Taking a look at this other pair of perpendicular lines, well, again, if I can find some points, then I can begin to think about finding some equations. Well, I've got 2 points there on my increasing line, 2 points there on my decreasing line. Again, counting rise and run. So I've got a rise here, no, sorry, rise of 1 and a run of 5. So this guy has a run of 5, a rise of 1. It's a decreasing line. So notice its slope is going to be negative 1 over 5. But for this guy over here, if I count its rise and runs, I'm going up 1, 2, 3, 4, 5, and over 1. So here we have a run of 1 and a rise of 5. Notice it's increasing, so its slope is going to be positive 5 over 1, which can of course be reduced to 5. But take a look at these fractions. What do you notice about the relationship between them? Take 30 seconds. Tell me something here about the relationship between these fractions. Go ahead. Alrighty, well, hopefully you've noticed here, the signs are flipped, right? I've got positive for one, negative for the other. But not only are the signs flipped, the fractions are flipped too. 3 over 2 and 2 over 3, 1 over 5 and 5 over 1. The fancy word for that are fractions, are reciprocals of each other. So the interesting thing for us to notice about perpendicular lines is that unlike parallel lines that have the same slope, the slopes of perpendicular lines are also related. We are going to call these negative reciprocals. What that means, right, is both the sign and the fraction is flipped. So it's negative, meaning one's positive, one's negative. I negated one of them. And it's a reciprocal. I took my fraction, flipped it on its head. Cool. So in the interest of formalizing this observation, just like we did with parallel lines, what that tells us here is that if I'm working with two lines that are perpendicular to each other, they have slopes. So say line 1 has a slope of m1, line 2 has a slope of m2. Mathematically, the way that we would write that they are negative reciprocals of each other, we would say that the slope is equal to the reciprocal of the other one, right, which is 1 over, and then it's negative, so it's times negative 1. Equivalently, right, I could say m1 is equal to negative 1 over m2, the negative reciprocal of m2. And equivalently, slope of the second line, m2, would be negative 1 over m1. So the negative reciprocal of my first slope. More simply, though, I think there's a more efficient way for us to document this finding. What this tells us here is if I have two perpendicular lines. Say that the first line has a slope of m1, which is some number a over some number b, right? A rise and a run. How could you express that slope 2 is the negative reciprocal of a over b? What would that fraction need to be? Take 5 seconds, 4 seconds, 3 seconds, 2 seconds, 1 second. Very good. Well, I need to flip the sign, so it's going to go from positive to negative. I also need to flip the fraction, so I'm going to flip a over b to b over a. Cool. So whichever of these definitions works better for you, either way, to find the slope of a perpendicular line, I flip the sign from positive to negative or from negative to positive, and I also take the reciprocal of my fraction. So I flip the numerator and the denominator. Fantastic. With this idea in mind, let's say, for example, that I wanted to show that negative 8x plus 10y equals 4 is perpendicular to 5x equals 4y minus 12. Take a minute, pause the video. Find the slopes of these lines and show that they meet the criteria. Go ahead. And stop. What do you mean you're raising an eyebrow? I don't know what you're talking about. So, if I want to find the slope, the easiest thing for me to do is probably to rewrite this in slope-intercept, or y equals mx plus b form. So I want to get y by itself. For the one on the left, let's start by adding 8x to both sides. That gives me 10y is equal to 8x plus 4, dividing both sides by 10. I'm going to divide each thing by 10. I know that y is equal to 8 over 10, which reduces to 4 over 5x, plus 4 over 10, which reduces to 2/5. So here's the equation of my first line. And then here for my second line, I already have a 4y over on the right side. Let's add 12 over here. So I'm going to take this as 5x plus 12 equals 4y. And then to get y by itself, I'm going to divide both sides by 4. 5 over 4x I can write as such, plus 12 over 4, which is 3, is equal to y. Notice I'm still in y equals mx plus b form, except my sides are flipped. So these lines are perpendicular. Notice I have a 4 over 5 and a 5 over 4. I've met my criteria, right? 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 Well, no! I have a 4 over 5 and a 5 over 4. What's missing? Well, they're not negative reciprocals, right? I know that the fraction is flipped, but one of them would need to be negative, one of them would need to be positive. These are not perpendicular. Cool. Lovely. So now, same idea as parallel lines. I know how to show two lines are perpendicular or not perpendicular. Let's say I want to find some equations. So I've got a line. It passes through the point 4 comma negative 1. It's perpendicular to y equals 2/9 x minus 13. Let's find the equation. So give yourself a minute, think creatively, pause the video. How can I use this perpendicular line to my advantage to build the equation of the line that I want? Go ahead, pause, play around, have fun. All right, let's do it. So I know that my line is perpendicular to this line. So this line has a slope of 2 over 9. Because my line is perpendicular, that tells me that my line's slope needs to be the negative reciprocal. So notice this is positive 2/9, so my slope needs to be negative. The reciprocal of 2 over 9 is 9 over 2. And now would you look at that? I've got a slope, I've got a point. All I need to do is use, surprise, surprise, my point slope form. So let me take my y minus y1 equals m times parentheses x minus x1. All I've got to do is substitute in. So I know y minus y1, which is negative 1, is equal to m, negative 9 over 2, parentheses x minus 4. All I've got to do now is simplify and solve. So I've got y plus 1 here, and then on the right I can distribute. Negative 9 halves x, well that's negative 9 halves x. Negative 9 halves times negative 4 would become positive 18. If you don't believe me, feel free to fact check me. All I've got to do now is subtract 1 from both sides to get y by itself. Y is equal to negative 9 halves x plus 17. Cool. There we go. So here's our equation. Again, as long as I know to find the negative reciprocal of my slope, I've got everything that I need for point slope form. Let's do a couple more. So I want to find the equation of my line. It passes through negative 14 comma 4, and it's perpendicular to y equals negative 7/3 x plus 1. Give yourself 2 minutes, pause the video, play around. Have at it. Okay. So once again, I know that the slope of this line, notice it's already in y equals mx plus b. So my slope here is negative 7/3. But my line is perpendicular. So its slope needs to be the negative reciprocal. So I'm going to take it, flip my sign from negative to positive, and flip my fraction from 7/3 to 3 over 7. Now I've got everything that I need to plug in to point slope form. So I'm going to take my x1, y1 here, and I know that y minus y1 is equal to m parentheses x minus x1. I'm a broken record, but broken records can still play good songs. Y minus y1 here, I'm going to take y minus 4 as y1. My slope I've identified as positive 3 over 7 times x minus negative 14 for x1. Simplifying, I know y minus 4 here is equal to 3/7 times x plus 14. Taking my 3/7 and distributing, that tells me that y minus 4 is equal to 3/7 x. 3 over 7 times 14, right? 14 divided by 7 is 2, and then 3 times 2 is 6. And then all I've got to do is add 4 to both sides to get y by itself. I know that y equals 3/7 x plus 10 should be the equation of my line. Fantastic! Congratulations, you now know how to find the equations of perpendicular lines. If you're interested in seeing what's coming up, here are 2 more variations of this problem similar to what we did with parallel lines where maybe the slope isn't so immediately obvious. This will be our warm-up next time. But until then, take care, enjoy your freedom from Unit 4. I'll see you in Unit 5 where we start talking about systems of linear equations. Goodbye!